Hello, and welcome to our webinar on reaching new milestones in optical gas imaging. My name is Craig O'Neill. I am the Global Business Development Manager for Flir's Optical Gas Imaging product line. I am excited to talk to you today about some new advancements we have in the optical gas imaging industry. But before we get into the new milestones as it relates to optical gas imaging, I want to take just a moment to make sure that everybody on the call can understand the history behind optical gas imaging, where we've come from, and how long it's taken us to get to the point we are today. As it relates to Flir, our first engagement in optical gas imaging was in the 1980s. At that time, the United States Army reached out to us from the Dugway Proving Grounds and asked us for some assistance in characterizing various chemical gas compounds. They've asked us to do this, and this was done mostly in utilizing infrared wavelengths and special or spectral filtering. And this is a general practice and a foundation of optical gas imaging today. In the 1990s, we took a next step in optical gas imaging with the first ever handheld or portable system that can be used for gas imaging. This was the Inframetric 760 camera, and it used a warm filtering system where the filter for visualizing gas was between the lens and the camera. It wasn't inside the camera or inside the detector. It was between the actual lens and the camera. Now, this does have some play when we talk a little bit about the milestones that we're going to reach today with our optical gas imaging technology. Now, our flagship year was probably 2005. The reason is this was the first time that there was a dedicated optical gas imaging system that was in the commercial market and with the gas find IR solution from Flir. In 2005, we launched this camera with a new horizon out there. We didn't quite know where this market was going to go, and since then, it's been a great product for us and a great product for the industry, the oil and gas industry, as it relates to optical gas imaging and visualizing gas leaks. It did take a little bit of time for this technology to get accepted through all industries. And in 2009, we took a next step. By then, a lot of the industries and a lot of our customers had accepted this technology as a proven technology for gas detection. Even the EPA, which is the regulatory agency here in the United States, they had accepted this as an alternative works practice for visualizing VOC and hydrocarbon leaks. And in 2009, we expanded upon and we took the feedback from the industry, from the Gas Find IR, and developed the GF series, which is still very popular and our flagship product today. Some of the additions were a complete new overhaul with ergonomics. We added some visual cameras. We added digital onboard recording via an SD card. We added GPS, which would be a foundation or a piece of the regulatory component of future regulations within the EPA, like the Quad OA regulation. And then we also added temperature measurement, which does play a key and integral part in optical gas imaging today, not just in just gas detection, but also in quantification. In 2017, we took another step for Flir in developing our first camera that was certified for use in hazardous classifications or hazardous locations. The GFX 320 is still probably our flagship product today. And we're really proud of the strides that we've made since 2017. But today, we're excited to talk about the next generation of optical gas imaging. Some of the new products that we have that include a product like the one you see here today on the image there, the first foray into uncooled optical gas imaging by Flir. A common question that we get when people look at our optical gas imaging portfolio is why do you have so many cameras? Why are there multiple cameras out there? And in the cooled systems, they're all at a considerable price point for many of our customer base. And the answer is in the gas. The answer is in the absorption of energy that each one of these gases have. A lot of these gases have individual characteristics in their what we would define as their peak absorption, where they absorb their the most amount of energy. If we look at the first, the red line there, methane absorbs a lot of energy in the midwave, right, at around 3.3 microns. Now, what's unique about this, and I'll talk in just a minute about this is also somewhat known as the functional region of optical gas imaging or infrared, where a lot of common gases absorb energy at a very common wavelength. But when we look down the line at some of these common gases that are not directly hydrocarbon or VOC gases, we look at carbon dioxide or CO2, carbon monoxide. All of these have a very unique and different characteristic with regard to their absorption spectra. If you look at our common refrigerant gases, R22 as an example, it has a unique characteristic for itself that is in line with a lot of refrigerant gases. And as we look at a gas that's very popular in the electrical utility industry, sulfur hexafluoride, again, all of these have very individual, but you'll also notice that methane has multiple absorption spectras, both in the midwave and in the long wave. And that's what we're looking at today with this uncooled system. Now that we have a lot of these gases in the long wave portfolio or the long wave spectra, this is where we're able to begin our adventure into an uncooled microbolometer type of gas imaging spectrum. As I mentioned, to show why we would still need the cooled solution. If you look at these graphs, these are some common hydrocarbon gases. And if you look at the spectrum right around 3.3 micron, you'll notice this is also known as the functional region of gases. All of these overlay right on top of each other. Now, if I look at that region and compare that to the long wave or the fingerprint region, you would notice that for propane and methane and benzene and ethylene, all of these gases have an individual or unique fingerprint of spectral absorption in the long wave infrared. So the long wave camera a single camera would be very challenging to manufacture to see all of these gases. And that's where the cooled operating system is still going to have a huge play in the market. So let's take a look at some uncooled and cooled optical gas imaging direct comparisons from the field. On the image on the left, or the video on the left, is just a small fitting leak. This is probably around a 30 or so liter per minute leak, and you can see the image on the left is the common image in black and white palette that we're used to seeing with the GF camera, GF320 camera from Flir. But that video on the right is an uncooled. This is the new product from Flir. This is an uncooled optical gas imaging camera in the long wave spectrum. So you can see that you can visualize this. The biggest difference between these two is we do take advantage of some of the newer features from Flir, like the palettes that may be a little bit more adaptive to an uncooled solution and uncooled technology. If I look at another video that's very similar, but this is a pretty large leak. We're guessing at around 350 to 400 liter per minute leak, and this is just a valve on top of a natural gas tank. You can see the image on the video on the left is a cooled camera, and you can really visualize those gas emissions much easier. But the video on the right, you can see those, and as you get to those large leaks, you're just going to get more detail with a cooled camera that has better sensitivity, better accuracy, and it just realistically, it's just a better camera for the application, whereas the uncooled camera does have its place in the market. And one of the exciting things about optical gas imaging with an uncooled system is potentially it allows us to penetrate and introduce the product to new markets. Maybe there are some markets that had been not quite as adept to accepting the technology. And this is the biogas industry. And this is just two videos. The image on the left, it's a little unfair that the cooled image is in our patented high sensitivity mode, whereas the video on the right, it's just an uncooled automatic level and span normal mode camera, and you can still visualize that leak. So we're excited about the industries that may have had a too much of a barrier to entry with the cooled systems, and where the uncooled optical gas imaging technology and the optical gas imaging systems with an uncooled microbolometer detector may take us. Now, I want to show a quick snapshot of some comparison, some differentiation. You'll notice on almost all of these specifications that there is a huge advantage for the cooled system. We do have our only certification for a hazardous location, ATEX Zone 2 or Class 1 Div 2 camera with our GFX 320 is in a cooled solution. We do have a cooled camera that has better resolution, which we'll talk about again today. But the sensitivity, both the thermal sensitivity for temperature measurement and the gas sensitivity for the NECL or noise equivalent concentration length. In other words, the sensitivity of that camera to see a certain size leak of gas over a distance. You'll see how much greater that is. It's probably 5 to 10 times greater with a cooled system versus an uncooled. Our minimum laboratory leak rate or a minimum detectable leak rate in a laboratory, you'll notice is about a 5 times difference. So we're looking at 0.6 grams per hour for our cooled systems. We're looking at around 2.7. This is still a very small size leak for our uncooled systems to be able to visualize that type of gas. But as we look at the visualized gases, as we talked about earlier, the functional region in the cooled midwave gives a huge opportunity to have one camera to visualize a large number of gases that are very consistent and common in their absorption spectra. Whereas the uncooled system, the advantage there is now we're reaching other gases that didn't have an absorption characteristics in a midwave system. Gases like nitrous oxide or sulfur dioxide are gases that didn't have an absorption spectra that could to allow us to visualize that. And now with an uncooled system, we can add those to our portfolio of gases detected with optical gas imagers from Flir. Unique features like quantification in the system and quantification mode are only available in our cooled systems because of the necessary to have that high sensitivity of the camera. But the best advantage for that uncooled system is going to be the price point. You're looking at less than 50% of our traditional popular cooled cameras price point with the uncooled system. So what do we have to show you? Well, again, we are extremely excited to introduce the GF77 to the market. Again, this is Flir's first uncooled optical gas imaging camera. It is manufactured specifically with certain design objectives and certain characteristics in mind. Those include versatility, making sure this camera is versatile to meet the future demands of the market. Usability, ensuring that the technician that has a camera in their hands, it makes that camera and the operation of that camera is extremely easy. Not only is it easy while they're in the field, it's also efficient. We understand that these operators want to get out there and they want to do their job with an optical gas imaging camera as fast as they can, but as good as they can. And we feel as though some of the features that we've added to this camera increase the efficiency for that operator and that user while they're in the field. And lastly, a dedication. This camera is dedicated to optical gas imaging. It's dedicated to those new milestones and the next generation of optical gas imaging. To elaborate a little bit, when I say versatility, this camera is designed and engineered specifically for gas inspection. But with that, the The special sauce in the camera are the lenses. What we've been able to do to combine some unique algorithms in the camera with the filtering on a lens is very similar to what was happening in the 1990s with the Inframetrics camera, where we added a lens in between added a filter in between the lens and the camera itself. We've actually added the filter mechanism within the lenses, but we've also stayed true to Flir. We've stayed true to our foundation, our principles of temperature measurement. This camera is going to give you what you expect to have a dual purpose camera while you're in the field and be able to do your standard temperature measurement applications, whether it be tank level inspection, whether it be electrical or mechanical inspections. While you're utilizing your optical gas imaging camera, you will have temperature measurement built into this. So we're going to have a camera for multiple applications. The usability of this camera is unique. This is built upon our award-winning T500 series platform. And what we've done is we've added some unique features, like a viewfinder, a very comfortable eyepiece that's built in. It is automated so that it turns on when it senses that your face or your eye is close to the camera and close to that viewfinder. We have a 4-inch full touchscreen LCD display that makes that user experience as seamless and as easy as we can get while you're in the field. And it does have our patented 180-degree rotating optical block with the Flir camera. So a lot of unique features built into the camera to increase the usability. But again, we want our customers and the technicians that use these cameras to be efficient. And that's why we've added some features like programmable buttons, extremely fast camera startup. So when you hit go, when you turn the camera on, in less than 1 minute, you can start inspecting and you can start looking for some gas leaks or for some methane leaks. There's work folders built into the camera so that you could assign a work folder for individual locations or individual regions. So make it easier for you when you get back to the office to already have some of those images filed away in the right locations. And there are those advanced communications and what you would expect from a new technology, a new product from Flir, like Bluetooth and Wi-Fi built into the camera. Again, working to make your work and your job easier. And then dedication. This camera is made with gas detection in mind. It might be on the same platform as one of our other cameras, but this camera was specifically developed with a microbolometer detector, what we're defining as a gas bolometer detector, and developed for gas detection. The uniqueness of the camera is the spectrally filtered gas lenses. Again, that does give us that versatility to expand this solution as we learn more about optical gas imaging with long wave and uncooled cameras. We have that great capability with our spectrally filtered gas lenses. And then all of our customers would expect the patented high sensitivity mode built in. Again, this is made for your OGI expert. This is made for those people that need a dedicated camera for their application. I don't want to get into all the features, but I want to talk just about a few of the features that we have built in. Again, the sensitivity of this camera is extremely, extremely sensitive. We are less than 100 parts per million meters, which is our noise equivalent concentration length for methane. Again, that is around 5 to 10 times greater than our cooled systems. But in the grand scheme of things, this is a very sensitive camera considering its place in the market. As I've talked a little bit about, the processing of the image is done through spectrally filtered lenses, as well as the unique Flir filter algorithms that we have in the camera to talk to and to associate with those optics. We have a gas table built in if you ever want to know, again, as we expand this camera, potentially have new lenses and additional lenses to support various gases in the market. You can simply turn on the camera and go to the gas lens information and see a table of what gases can be detected and what lens is on the camera. We do have some of those advanced gas detection features. As I mentioned, you would expect those from Flir. High sensitivity mode, it is different than our cooled system. A high sensitivity mode in this camera is just on and off. You simply turn it on and you turn it off with things like a user-defined programmable button. We also have our very, very popular One-Touch level and span, which was built into the T-Series camera and is also in our EX5 series cameras. This is where you can simply turn the camera from automatic to manual level and span and touch the screen. Now, what this does when you're looking for a gas leak is it optimizes the gas contrast so that you can much easier detect that gas and the smaller leaks in unique environments. And lastly, there is a laser built in, and that laser is not just for designation of what you're looking at. The laser has advanced features like laser measurement, so to tell you exactly how far away you are from equipment. Maybe this is to ensure that since this camera is not a Class 1 Div 2 compliant camera, you can ensure through your camera and through the laser distance measurement that you're the correct distance to meet the requirements that your company has on distance away from components. But you can also turn on the laser for continuous focus. The camera will look for that red dot and always focus on wherever that red dot is pointing. So, advanced gas detection and advanced features built into the camera. Now, the next question I expect is, okay, Flir, you're coming out with a lower cost solution and an uncooled. Where are you going to go? Are you going to abandon your cooled solutions, and are you going to move towards the uncooled technology? Well, the answer to that is a resounding no. That's why today I would like to also introduce the biggest of big brothers in the optical gas imaging portfolio from Flir, the Flir GF620. This is our first high definition optical gas imaging camera. This has 4 times the resolution of our popular GF320 camera with 640 by 480 pixels to give you unmatched performance, to give you unmatched image quality as it relates to optical gas imaging. A few of the key features that I'd like to highlight that we've seen in the GF620. The first one is again that improved resolution, but that doesn't just give you a pretty picture per se or a pretty video. As I look at these videos, it's somewhat hard to see the difference. But as I pause the videos and zoom in, if I look at the legacy cooled camera, the GF320 and the GFX320 in the image, this is the image we're used to seeing, just a smoke-looking type of image of a leak coming out of a facility or of a testing facility, and this is a lab in this case. But if I take that image with the GF620, I begin to get full detail of the turbulence of that gas leak, see where it's going, where it's coming from. I get better detail on the background. And we fully expect this to work very well with our quantification systems in our partnership with Providence Photonics to be able to quantify better with a higher resolution and a better quality infrared image for optical gas imagers. As we talk about quantification, today we're also launching a unique characteristic or a unique feature from Flir's family called Q mode. This is quantification without wires. What we're able to do is in the field, you're not going to get quantification in the camera, but in the field you can store a file that gives you the capability to post-process that file with a Providence QL320 after you're back in the office. Maybe you're just right back in the truck. Now, a huge advantage is utilizing the GFX320 in a hazardous location, so we can take a camera into an area where the Providence QL320 does not meet that hazardous location rating, take the recordings and bring it back. Now, again, as you've noticed, this is with the GFX 320. So the Q mode will be added to all new GF 320s and GFX 320 models, and it will be available for upgrade within models that are in the field. How does it work? Very, very simple. There are some drop-down menus that are built into the QL320. They're on the right side of the screenshot. We take those menus and we throw those into the actual camera, and then you just put those in while you're in the field. You would still have some limitations, like using the camera on a tripod, because you still need a fully consistent image that has very little movement. But you just simply take the video with these inputs, and now you can quantify after the fact. Again, whether you're in your truck, back in the office, send it to a colleague, however you want to do that. We've also noticed that the high sensitivity mode of this camera, of the new versions of Flir with the 620 camera, are increased. You can see a little more noise in the background on the video on the left, whereas the stop video on the right is a little bit cleaner to be able to see that leak. So when you get this camera, you get out in the field, we feel as though you'll notice that the HSM mode and the advancements that we've made in that technology are going to be very easily seen with the GF 620 camera. I do want to highlight, again, we're launching two great products, from an uncooled technology at an extremely affordable price point for the market, to a new high-end, first ever high definition camera of this. But there are advantages. There are huge advantages of our uncooled system, and the biggest one is that price point. But there are advantages to the cooled Flir technology. Those would include the ability to see multiple VOCs, over 400 confirmed gases that we can visualize with the cooled systems cannot be seen with the GF77, or many of them cannot be seen. For example, benzene and butane and hexane, these are gases that have very, very little to no absorption in the long wave spectra. With a cooled system, you just have a better detector. You're going to have a camera that has better sensitivity. You're going to have a camera that has improved image quality. You're going to be able to see smaller leaks. Now, a question that I'm sure is going to come out is, as this relates to regulatory compliance with both of these cameras in the portfolio. The GF77 does not meet EPA regulatory compliance for rules like the Quad OA rule at this time. So the cooled technology has its place in meeting regulatory compliances because of the increased the increased sensitivity, almost 5 to 10 times increased thermal sensitivity and gas sensitivity within the camera. Unique features like quantification and Q mode are only going to be available in our cooled technology, but you're going to have increased temperature measurement accuracy because that camera does have better sensitivity with the high definition we've discussed, and the only camera in Flir's optical gas imaging portfolio right now that has a hazardous location classification or certification is going to be the GFX 320. We also have some new accessories coming out. One of those is our bag and harness. We've had some customers that have asked us that, hey, the neck strap you have is nice, but it doesn't quite fit my needs. I would kind of like to have a harness that overlays. You've got a neck strap, you've got a harness. It's harder to take on and off sometimes when you have a hard hat on. So we will have in the images on the top, you're going to see a harness where the camera is going to be attached to a harness that's going to be wrapped all the way around you and be, just make your work environment safer during your inspections. On the bottom, you're going to see the pouch, and this clips on to a harness, to the same harness, where it allows you the capabilities to just very basically take this pouch off when you need to get in and out of your truck. So you don't have to take the entire harness off. You can drive from point A to point B, or from well pad to well pad, or from location to A to another location, simply taking this pouch off. And so really unique in the way it works. And we're really proud of this, and this will work with the entire suite of our Flir GF optical gas imaging cameras. Another thing that we will have coming soon, and we're really excited, is software specifically for optical gas imaging. We have a software suite that will work with all of our GF series cameras called the Flir Thermal Studio. You'll be able to do things that have been a challenge in years past without some software dedicated to our optical gas imaging portfolio. Things like pulling a single snapshot out. You've had to use third-party software sometimes to do that. Editing a video, you just simply can edit a video, add markers, and add tabs right on the video, and then cut that out, cut that part out that you would want to have within your saved video. We've also got some GPS updates with some of the Quad OA necessary requirements with GPS. We now have that solution to ensure that you can link those, you can find those GPS data coordinates very easily. You can link those to Google Maps, and they actually replay live in this software. So if you were using your camera in a helicopter or in a truck, or you're using the camera on a drone, you would watch, as you played the video, you would watch the little red marker there move and completely be in line with where that camera is in those GPS coordinates as it tracks the location of that camera through the software.